A warm welcome to one and all. So in this session, we will be discussing mainly reciprocating pump and centrifugal pump. This will be coming in the 5th module of Basics of Mechanical Engineering subject. Now the objective of this session is, first we have to discuss the basic principles of fluid mechanics that helps to understand the working of pumps. Then we will study the definition of pump, the specification and efficiency, how to calculate efficiency of a pump, classification of pump. Then after that we will go to the identification of parts of a reciprocating pump, then working of a reciprocating pump. Then we will go to centrifugal pump, identifying the parts of a centrifugal pump, working of centrifugal pump. And finally, we will compare these two pumps, reciprocating pump and centrifugal pump. Now try to answer this simple question. That is, suppose you have a pipe like this, and initially it is having this much area at section 1, and going to section 2 the area decrease. So what will happen to the pressure of water flowing inside? So just think about this and come up with an answer. So we have a pipe of decreasing area. So what happens to its pressure? So please answer this question by yourself. And most of you have arrived the answer that the pressure will be increasing because pressure is forced by area. So area is decreasing means the pressure will increase. So we have to clear that misconception. So in this, the pressure will be increasing, not decreasing. So the pressure will be decreasing, not increasing, as you accept. So let's check how the answer comes. So first we have to study continuity equation. So what is continuity equation? It's derived from conservation of mass. And it tells that for an incompressible fluid like water, the product of area and velocity will be a constant. So area into velocity in any section of water flowing, the area of that pipe into velocity in that section is a constant. And this is known as rate of flow. So when area decreases, the velocity will increase. So you can see here this simple equation, continuity equation applied to water is a simple equation, that is this one. As the density of water is constant, 1000 kilogram per meter cube, water is incompressible fluid. So its density will not vary when pressure or anything varies. So that means only area into velocity for water, incompressible fluid like water, area in any section into velocity in that section is constant. So if the pipe is decreasing its area, its velocity must increase. So that means velocity will increase when pipe area decrease. What are the application? We have applied this in any of real life or in any other industries. A lot of applications are there for continuity equation. A simple example is, if you are watering your garden using a hose, you might have done this. You might have reduced the area of pipe by blocking it with a finger so that it can increase the velocity and it will reach more distance. Similarly, if you consider the chimney of an industry, most of them will be designed like this. So in any industry, you can see here the area is decreasing gradually. When it comes to its opening, the initial area decrease. So why the area is decreasing? Because to increase the velocity, so that the exhaust will go out and reach the higher distance. So like that we can find a lot of application for continuity equation. Now we have one more equation that will help to understand the working of pump, that is Bernoulli's principle. So Bernoulli's principle is derived from conservation of energy. So what is this Bernoulli's principle? So we have different expressions. So one is the pressure energy plus kinetic energy plus potential energy. The total energy of a fluid flowing is a constant. So these are the three types of energy that we will come across in a fluid: pressure energy, kinetic energy, and potential energy. So these are a constant. Or you can express in different terms like this: P by rho plus V square by 2 plus Gz is a constant. First term is corresponding to pressure energy, second term is kinetic energy, third one is potential energy. Or in terms of head also you can write, if you want to convert this equation in terms of head, all in terms of head, you can express like this: P by rho G plus V square by 2G plus Z is a constant. First one is pressure head, second one is kinetic head, and third one is potential head. So that means now we have come across the final answer of the first question. So if the area is of a flow or a pipe is decreasing, by continuity equation the area decrease means velocity should increase. Now you apply this in Bernoulli's equation. Apply this in Bernoulli's equation. Here the area is decreasing, pressure velocity will increase. So that means the potential energy is a constant. If pipe is in same level, the potential energy is constant. So you can neglect that term. So that means if area is decreasing, velocity must increase and simultaneously pressure must decrease. So that is the final answer. When area of flow decreases, pressure also decreases. Similarly, when area increases, pressure will also increase. So you have to understand these two principles. And Bernoulli's principle also have several applications, numerous. A few are the working of aerofoil. So aerofoil will have a shape like this, and this shape, one upper region will have more distance, so as to pressure, change the pressure. So like that, different applications are there. And another example in real life is swinging of cricket ball. So the bowler will make one surface rough, other one smooth, so that it will pressure will be different, and you can in swing or out swing the ball using the holding of this seam. And toppling of our umbrella in wind, that is another example of Bernoulli. So a lot of examples are there. So you have anyone interested, you can check the application of Bernoulli's principle. Now we are going to the definition of pump. So what do you mean by a pump? A pump means a device which converts mechanical energy to hydraulic energy. That is the standard definition of a pump. And hydraulic energy means it is a sum of kinetic energy, pressure energy, and potential energy. So these are the three energy that will come across in a flowing fluid. The fluid will have some kinetic energy, it will have some potential energy, and it will have some pressure energy. So sum of this is known as hydraulic energy. So pump will convert mechanical energy to hydraulic energy. And in common words, we can say a pump can lift water from a low level to high level, or it can transmit water from one place to other. And where this mechanical energy is obtaining, the mechanical energy means some rotation, some work we have to given to the pump. So this will be obviously given by an electric motor in most cases. So every pump, most of the pump will be coupled with an electric motor to provide the mechanical energy. So here also you can see This is a figure of a pump. So only this is the pump region. This one is an electrical motor. So every pump is coupled with this an electrical motor to provide the mechanical energy. Now we are going to the specification of pump and how to calculate the efficiency using these specifications. So what are the specifications of a pump? Two specifications are there. First one discharge and another one is head. So what do you mean by discharge or rate of flow? It's denoted by the letter Q. Discharge is the amount of water flowing per second through a particular section. So it is a volume or the amount of water flowing in any region in 1 second. So the unit of this, the SI unit of discharge will be meter cube per second. So if you have in centimeter cube or liter per second, you have to convert that into meter cube per second. Now what is head? Head is a measure of energy possessed by the water. So head means it is a total energy. It is equivalent to the total head, the kinetic head. So in the Bernoulli equation, you can see three heads: kinetic head, pressure head, and potential head. So head means the total head means the sum of these three heads, and it represents the total energy. The energy is represented in head. So more head means the water is having more energy. And the SI unit of head is meter. Now you have these two specifications now to calculate efficiency. So we know efficiency is simply output by input. So how to calculate output? Output is hydraulic power. We know the output of a pump is hydraulic energy. By its definition, we know that. So hydraulic power is calculated by a simple equation. Just understand this equation, that is output of a pump. The hydraulic power is given by rho QGH. Now rho is the density of water, Q is the discharge, it's one of the specification. G is the acceleration due to gravity, and H is the head in meter. So density of water, standard value 1000 kg per meter cube, acceleration due to gravity 9.81 meter per second square. So all two are, these two are constant, only variables are Q and H, that is discharge and head. So we have to simply substitute in this expression. Now what is the input of the pump? So input is given by an electrical motor. So in some questions it will be directly given as the output of motor or input of pump. But if the electrical power consumed by the motor is given, you have to multiply by efficiency of motor, because some energy will be lost in the motor. We are giving electrical energy to the motor, some energy is lost and some is converted to mechanical energy, and we are giving it to pump. So if you have to calculate the input of pump, we have to multiply the electrical input of motor into efficiency of motor. The efficiency of motor will be normally 90% or above. And efficiency of pump, we can know output by input. We can just calculate and express in percentage. So this is the procedure for calculating efficiency of the pump. First find out the hydraulic power output, find out the input power to the pump, then just divide and express in percentage. Now we are going to classification of pump. So this is a broad classification of pump. So you can see here the entire pump we can classify into two categories. One is dynamic pressure pump or rotodynamic pump. Another one is positive displacement pump. So again we can classify dynamic pressure pump into a number of categories and positive displacement pump into number of categories. So we don't have to bother this because we have only in the syllabus we have to study only two pumps. Two pumps only we have to study, and that is this centrifugal pump and reciprocating pump. So we can see here reciprocating pump is a positive displacement pump. Centrifugal pump is a dynamic pressure pump or a rotordynamic pump. So you have to memorize that only. Reciprocating pump is a positive displacement pump. Centrifugal pump is a dynamic pressure pump. Now we are going to the reciprocating pump, the first pump we have to study. So this is a figure of reciprocating pump. This might you have already drawn as an assignment. So just identify the parts. So it's a positive displacement pump. Why it is a positive displacement pump? It works by the displacement of this piston. So a particular volume is contracting or expanding. That working volume is displacing. So that is why it is known as a positive displacement pump. So what are the parts? So main part is this one. A piston reciprocating inside a cylinder. Just like IC engine, here also the main part is a piston. This piston is there reciprocating inside a cylinder. So this is the cylinder. The next part is a piston rod. We can see a piston rod, this horizontal one. It connects the crank through a connecting rod. So just like IC engine also, here we have a connecting rod and crank. But in addition to that, we have a piston rod also. In IC engine, you will not see a piston rod. You will see only connecting rod and crank. So these are the major parts. A piston reciprocating inside a cylinder. It can go left and right. And a piston rod and connecting rod is arranged like this to connect to the crank. Now the crankshaft, the center, at the center or perpendicular to this plane, we have a shaft known as crankshaft. This center point represents the crankshaft. That will be coupled to the shaft of an electrical motor. So our electrical motor will be here at the center, coupled to this crankshaft. Now obviously you can see the type of motion converting here. The crank will be rotating through this circle from A to C, A to C. And this link will move, and finally the piston will be moving in left and right. So we are converting the rotary motion of crank into the reciprocating motion of piston. And what are the other parts? So this is our major part, this region. Another part is more or less common to every pump. We have a suction pipe. This is the suction pipe where the water is to be lifting from the sump. So this is known as sump. So where our water is initially collected, the lower level is known as sump in fluid mechanics. So this is our sump or sump level. So this is our suction pipe. The suction pipe connects sump to the pump. Then we have a delivery pipe. This is our delivery pipe which connects the pump to the delivery tank or wherever we have to deliver this water. So tank will be here, or wherever we have to collect the water, some vessel will be there. So this pipe will connect that to this pump. And what are the remaining parts? Yes, two valves are there. You can see here a suction valve at the entrance of the pump, and similarly a delivery valve at the exit of this pump region. And what are the peculiarity of this valve is they are one-way valve or non-return valve. So what do you mean by one-way valve? Yes, it can be open and closed in only one direction. So it will be open and closed in one direction. And here it is the upward direction. So this valve will be open only in the upward direction, and it will not open in the downward direction, both these valves. So that is the importance of these valves. So this is the overall parts of reciprocating pump. Now we are going to the working of a pump. So our aim is to lift water. So what is our aim? Initially water is here. We have to somehow lift water to here. So for that we will be using a simple principle. What is that principle? What is the pressure of water or pressure at these two regions here? Sump is open to atmosphere. So the pressure will be more or less atmospheric pressure. Here the tank also open to atmosphere. So here also the pressure will be atmospheric pressure. So that means these two regions are more or less same pressure. So our aim is in fluid mechanics we know that a fluid will flow only from a high pressure region to a low pressure region. So that means if you are simply connecting a pipe like this without any pump, suppose you are not have any pump and you are simply connecting a pipe like this to the sump, the water will not lift to here because we know that the pressure is constant in these two regions and water will not get lifted. So if you want to lift water or move water, you have to create some high pressure region and some low pressure region. So that is what this reciprocating pump does. So let's check how the working of reciprocating pump is. You have to start from here. When the crank moves from A to C, the first half cycle from A to C, the piston will be moving from left to right. So the piston is now at left, will move to right. And initially air is present. Suppose air is present, no water. So the movement of piston will drag the air towards the right. So that will create a vacuum pressure. So what do you mean by vacuum pressure? Pressure less than atmospheric pressure. So these things are happening. In the first phase, the piston moves from left to right because the crank is moving from A to C, and that will drag the air towards the right, and we will create a vacuum pressure. Now what will happen? Now the pressure at this region is vacuum pressure, but here we have atmospheric pressure. So you can see here we are creating a pressure difference. So pressure at inside is more, here it is less, here it is less, here it is more. So the water will be get lifted and it will enter into the cylinder. It will open the suction valve. Due to this pressure difference, it will open the suction valve and it will enter inside the cylinder. So that is what happening in the first phase. Piston is moving, it drags air, creates vacuum. The pressure is less than atmospheric pressure, but at the sum we have more pressure, it is atmospheric pressure. So obviously the water will lift and reach the cylinder. Now what happened? Now we have water inside the cylinder. Up to this we have obtained water. Now in the second phase we have to again move this water from here to the tank. So how it happens? Yes, in the second phase the crank moves from C to A. Now the crank is moving from C to A. Next 180 degree, the piston will be moving from right to left. So what will happen? Already the water is inside. It will pressurize the water. It will compress or it will try to pressurize the water. The pressure will increase more than atmospheric pressure. So now while moving from right to left, it will pressurize water and water will be at a pressure of more than atmospheric pressure. Now here we have only atmospheric pressure. So again we have created a pressure gradient. So this delivery valve will open and water will be get lifted to the tank. So this working is more or less simple. You just compare the working of a syringe. You have you have worked with a common syringe, medical syringe. What happens is similar to the reciprocating pump. We are pulling the plunger of that syringe, a vacuum created, water will get inside from a bucket or wherever it is, and we are again pushing the plunger, the water will get out. So like that here also, but the only difference is we are connecting a crank for continuous motion. So this is the working of reciprocating pump, and this will be repeated in every revolution of the crank. And reciprocating pump is used for high head and low discharge applications. So it is mainly used for high head and low discharge. And what are its advantages and disadvantages we will see in the comparison of reciprocating pump and centrifugal pump. Now before going to the centrifugal pump, just identify the difference between centripetal force and centrifugal force. So in centrifugal pump we will be utilizing the centrifugal force. So what is this difference? Difference between centripetal force and centrifugal force. Is there any difference? Let's compare these two figures and find the answer. Yes. In centripetal force, we are trying to execute a circular motion to an object. So we are trying to exert a force on an object so that it will move in circular motion. So it is an active force. And magnitude is mv square by r. What is the direction of that force? It is radially inward. So you have to apply a force radially inward to rotate this object in circular motion. So it is an active force. Now what is centrifugal force? This figure. So already we have an object which executes circular motion, and if a particle or string is attached to that object, it will experience a reactive force. So that is centrifugal force. What is example for centripetal force is a shot put, just like this figure, a satellite. All these are examples of centripetal force. Now, centrifugal force is a reactive force, and it is exerted by the object moving in circular motion to the particles or strings attached to the object. So you can see here some strings are attached to the giant wheel. It will experience the radially outward, and its direction is the reverse. The direction of centrifugal force is radially outward. So we have to understand the difference. In centripetal force, it is an active force, and it is a force we have to execute an object to obtain a circular motion, and its direction is radially inward. Centrifugal force is a reactive force, and its direction is radially outward. And examples are a giant wheel, a centrifugal pump. A number of examples are there. So our centrifugal pump uses this force, this reactive force, radially outward force, for the working of this pump. Now identify the parts of centrifugal pump. It is entirely different from reciprocating pump. So you can see here some parts are same, just like suction pipe, delivery pipe, but the main part is entirely different. So what is the main part? Yes, it is an impeller enclosed in a spiral casing. So this central circular disc, or known as impeller. So impeller is nothing but a circular disc on which a curved vanes, as backward curved vanes, are spaced on the periphery of that circular disc. So that is an impeller. So this is the impeller of this centrifugal pump. So it has some curved vanes at the periphery of that disc, which are at equal distance. And it is mounted on a shaft at the center. Here you can see a shaft of the centrifugal pump, this one, and it is connected to some electrical motor, coupled to some electrical motor. And this region, the center region of the impeller, is known as eye of the pump or eye of the impeller. So you can see here this circle or this central region is known as eye of the impeller. Another important part is this spiral casing. This impeller is enclosed in an airtight spiral casing. And what is the importance of this casing is, you can see here its area is increasing. The area of cross section of this spiral casing gradually increase. So you can see here at the inlet we have only this much area. When it goes at the outlet, it increases to this much. So area of flow obviously increase. And we have here also a suction pipe is there which connects the sump to the pump. And you can see the suction pipe, you can see some dotted lines. That means it is not connected to here. It does not end here at the casing, but it is end here at the eye of the impeller. So that is an important thing. While working, understand the working, you have to clearly understand this. The suction pipe connects sump to the eye of the impeller, not at the casing, because we have dotted lines here. It shows this is on the other side of the plane. So that is suction pipe. And we can, another thing is here the valve, suction valve is not at here, just like reciprocating pump, but it is at the end. At the lower side we have a valve known as, so it is known as foot valve. Since this is at the bottom part, we call it as the foot valve. So the lower part of suction pipe is fitted with a foot valve, and some strainer we can attach. Strainer means some wire mesh. It's a wire mesh used for filtering mud and other foreign particles. So these come at the bottom of the suction pipe, the strainer and foot valve. And what are the other part? Yes, we have a delivery pipe which connects the pump to the tank. So foot valve, and foot valve is just like reciprocating pump. The foot valve also is a non-return valve. It does not open in downward direction. It opens only in the upward direction. And delivery pipe is there which connects the pump to the delivery tank. So we can vary the flow. Here the delivery valve we can control. If you want, we can close or open or change the flow. So we can control the flow of water using the opening and closing of delivery valve. So these are the parts. We have impeller, spiral casing, suction pipe, foot valve and strainer, delivery valve and delivery pipe. Now let's check how the working takes place. And before working a centrifugal pump, this is very important. We have to, priming must be done. So what is priming? Centrifugal pump, we have to do priming. Priming means before switch on the motor, we must fill water to this casing and this suction pipe. So we must ensure that this casing and this suction pipe must be full of water, and that procedure is known as priming. And why it is required? Because we want to remove the air and other vapor from the suction pipe and casing. So no air must be there. So if you are filling water means you can ensure that it is full of water, no air is present. And what happens if air is present or water is not there? It's because the vacuum created. So we have to, the initial phase, we will be creating a vacuum at the eye of the impeller for sucking water. And if that vacuum created is proportional to the density of fluid. So simply speaking, we can say that whatever the fluid is here at the eye of the impeller and whatever its density, we can create a vacuum of that much proportion only. So you already know the density of air is around only 1.1 or near 1 kilogram per meter cube only. So it is, water is 1000 times more denser than air. So if air is present and simply we are rotating the impeller, we will not create any vacuum. So the pump will not lift water. So that is why the priming is important. So what is priming? It is the filling of water at this casing and suction pipe before starting. And why it is required? We want to remove air and other vapor from this region, because if they are present, their density is less and they will not produce any vacuum for sucking water. So that is the problem of air and why priming is required. Now suppose now we are done priming and how the working takes place. So now we are full of water. Here suction pipe and impeller is full of water. Now we are switch on the motor. This will rotate, the impeller will rotate and it will create a centrifugal force. So the impeller is in circular motion or rotation and water is in contact with the circular device. So a centrifugal force is created, a reaction takes place and water will be pulled radially outward. We already discussed that the centrifugal force is radially outward. The water from this region will pull to the radially outward region. So what will happen here is, initially we have water, suddenly it is removed from here, means it creates a vacuum. So that is how the vacuum is created. The sudden removal of water from the eye of the impeller creates a vacuum. And we have here the pressure is atmospheric pressure. Here we have vacuum pressure. The water gets lifted through the suction pipe. So similar to the reciprocating pump, here also we are creating vacuum, but the principle is different. There we are creating vacuum by the piston movement. Here we are creating vacuum by the centrifugal force and removal of water. So that is the first phase. Now the water will be pulled. So it will happen continuously. The water will get sucked. It will reach here. It will experience centrifugal force. It will be pulled radially outward. Again a vacuum is created. So that happens continuously. Now once the water gets radially outward, what will be its energy? It will have some pressure energy and kinetic energy. It will have some velocity and it will have some pressure. And that water is moving through this casing, this spiral casing. You can see the arrow here. So the water sucked up, reached the eye of the impeller, it pulled radially outward, then it moves through this spiral casing. Now here comes the importance of its area. The area of the spiral casing is increasing. That means velocity, by continuity equation, velocity will decrease or pressure will increase. So we are converting, then the kinetic energy is converted to pressure energy by this change in increasing area. So when the water is going through this casing, when it reaches the outlet here, it will be a very high pressure water. And this high pressure water will be opening the delivery valve and it will go to the, or it will not need to open delivery because we are opening it in a particular position. It will go to the delivery tank because here we have high pressure water, delivery tank, we have only atmospheric pressure. So this will reach the atmosphere tank. So that is the working of centrifugal pump. So once again, this is we can see it in two phases. The first phase, we are lifting water from here to here. So how it happens? Initially we are done priming. We are filling water in this spiral casing and pipe, and the impeller is on. It will start rotating. It will create a centrifugal force on water. The water gets pulled and the removal of water will create a vacuum pressure. So again it will suck water. And this radially outward water will go through the casing where the area is increasing, kinetic energy decrease, pressure energy increase, and it will lift to the tank. And another important thing is the priming is not required in every operation because only at the initial phase we have to do priming. If the first day, if you are operating on the first day, we have to do priming. In the second day, the first day water will be here. So you don't have to again fill water. It will be already the water is there in the previous day. So only the priming is required in the first operation or some leakage of foot valve happens. Now we have discussed the working of reciprocating and centrifugal pump. Now just summarize and identify the comparison of reciprocating pump and centrifugal pump. What are the major difference? Yes, these are the difference between these two pumps. The working principle is entirely different. Reciprocating pump is a positive displacement pump. Centrifugal pump is a rotordynamic pump. It works by dynamic action of the rotor. And the main part is also different. Reciprocating pump, we have a piston reciprocating inside the cylinder, while the centrifugal pump, we have an impeller rotating in a spiral casing. And another important thing is reciprocating pump will produce high head compared to centrifugal pump. Centrifugal pump, the head will be low, but on the other hand, it will produce high discharge. So that is a major comparison of these two. The reciprocating will have high head and low discharge. Centrifugal pump will have low head and high discharge. So both are inversely proportional. We have out power is rho q gh, rho and g are constant. So this discharge and head are inversely proportional. So one is high, the other one will be low. One is low, the other one will be high. And another important limitation of reciprocating pump, why we are not using reciprocating pump in our household, is this point. The nature of discharge. Reciprocating pump have a pulsating and non-uniform discharge. So you can just memorize or recollect that reciprocating pump, we are not continuously pumping water, because only at the first half of the crank revolution we are not getting any water to the delivery tank. The water is just getting lift to the pump only. And in the second phase only we are getting water to the delivery tank. So that means it is not a continuous discharge. But the advantage of centrifugal pump is its discharge is continuous and uniform. So that is why we are not using the reciprocating pump. One of the reasons of not using reciprocating pump for our household applications. Then noise and vibration. Of course, the reciprocating pump is having a cylinder which is highly oscillating. So it will have more vibration and noise compared to centrifugal pump, where we have the major component is simply rotating. No vibration is there. Then another important point, priming. It is not required in reciprocating pump. Even though only the air is there, it will work. Initially, if air is there in the cylinder, it will work. But in centrifugal pump, it is a must. Priming is necessary. We have to fill water at the casing and suction pipe. Then space and weight. We know the reciprocating pump occupies more floor space because it have a lengthy piston, connecting rod, piston rod, etc. But centrifugal pump, this is the main advantage. It's a very small device. Space and weight is less. And lubrication and maintenance also more for reciprocating pump, less for centrifugal pump, because vibration and noise are less. We don't have to lubricate more. Then operating speed. Here also reciprocating pump cannot be operated in very high speed, so it is limited. But centrifugal pump we can operate in high RPM regions. Then working fluid also. Reciprocating pump, it will not pump highly viscous liquid. It is used only for low viscosity fluids. But centrifugal pump, it is not that much matters. We can use high viscosity fluids also. So this is a broad comparison of reciprocating pump and centrifugal pump. So just list out what are the advantages. We can see the advantage of reciprocating pump is only a few. Only one advantage is having high head only, and most of them, and it does not require priming. So these two are the only advantage of reciprocating pump. It produces high head no priming is required, and all others are disadvantages of reciprocating pump. Discharge is low, discharge is non-uniform, noise and vibration is more, space and weight require more, maintenance and lubrication more, operating speed very low. So most of them are advantages of centrifugal pump. That is why we are preferring centrifugal pump over reciprocating pump in most of the application. So with this we are stopping this session, and in the description we will add some animations of these pumps so that you can identify the working more clearly. So please study this and discuss with your classmates. Thank you.